이거를 아예 치워버렸군요. 네. 문제가 없나?
저번 자료보다 괜찮은 것 같아요.
그럼 학생들이 얘기하는 거는 어떻게 들어가요?
좀 온라인서
아니, 여기 학생들이 얘기하는 거. 마이크가 이거 말고 또 있나? 이런데?
PC 마이크를 지금은 사실 파악이
그러면 저쪽에서 얘기하는 거 하나도 녹화가 안 되잖아.
다음 때 한번
그러니까 녹화된 거를 한번 보시라고.
네.
그리고 그 온라인 들어온 사람들한테 컴플레인을, 컴플레인 잘 안 하긴 하겠지만,
스피커를 중간에 하나
그래서 보통은 이게 사실은 얘기하는 사람이 들고 가서 얘기하면 더 좋거든. 그러면 녹화가 녹음이 잘 되는데, 이 사운드가 사실 더 중요해요. 우리 이거는 거의 안 봐요. 사실 이거는 보지만 사람 얼굴은 거의 안 보거든. 그래, 사운드는 중요해. 이게 온라인 속에서 사운드가 제일 중요해. 제일 중요해서. Alright. Welcome back. Any question? You have? I know that everybody inside the Kakao group now. Did you get my message and files today, yesterday? Who is missing? You should check with the TA or for me. Right, the schedule today, last week we did overview finished, and then today we start with the textbook 2 on starting with the coastal processes. And homework 1 is out already through the Kakao. You have 2 weeks to finish, and then I will show you the tips for discussion session today. And then on Thursday, we will have a check with find out, make a flash hour, and also make a project team up. Then next week, we start with student lecturing and also student lead discussion session. Right? No question? Then I can continue on slides. Coastal processes and ocean observation. So this is the book, the textbook, second textbook, Ocean Engineering. You see that the picture looks like a drill ship, drilling tower. You need to drill the seabed to find out any oil or gas reservoir. Trying to find out, exploring. Problem is the depth of the water is nowadays 2 kilometer, 2,000 meter water depth. And then you start drilling there. And drilling also go to say several kilometers down. So that total length of the drill pipe can be more than 5 kilometers. And you see that the drill tower looks like say how many meters, something 50 meters, something. And each piece of pipe less than the length of the tower, height of the tower. Then you need to connect, down, and then drill. The final depth is say pipe length is 5 kilometers, 50 meters, 5 kilometers. How many pieces? 100? 5 kilometers, 5,000 meters, 50 meters. This 100 of them should be connected, and then drill, rotate. And drill bit is at the end of the pipe, 5 kilometers down. So you need to have a lot of pipes on board somewhere. And then you need say some kind of crane to handle that pipe. Stand up the pipe to go down to the, and then connection. So you will see a video in the due course later, not today. So today is about chapter 4, coastal processes and structures. And then the chapter 4 is made of, the textbook is made of coastal structures, wave reflection, diffraction, deflection. Very similar wording, right? For me, still confusing too. I cannot remember. Sometimes reflection, diffraction, reflection, and wave run-up, wave forecasting, hindcasting, sediment, transport, rubber mound structure, dredging. We already see the dredging, pipeline transport, of dredged material, or usually sand, and dredged material placement. So in short, because it is not a long lecturing, only 2 pieces of lectures of 20 minutes. There is short, smaller size. Hind casting, secondary flow, or Ekman spiral, Oberlin lip current, global currents and loop current and JRS. Fully develop sea and wave breaking, wave reflection, internal waves, and tidal circulation. We'll see what it will be. Hind casting. So hind casting is input, estimated input or past event entered into the model, mathematical model, simulation model, to see how well the output matches the known result. So hindcasting is a reverse word to the forecasting. Think about you are trying to forecast the weather. Weather for, say, after 1 week, what will be the weather forecasting? Because weather forecasting is very difficult. It's not fit well. You know that forecasting is not good. So how can you do that? Well, you need a forecast, but still it is not easy to match, to have a correct answer. So in the casting, you have a say CFD. Have you heard of what is CFD? Or CFD? All right. Computational fluid dynamics. Computational aerodynamics. We need such a model, computational model, to make a weather forecasting. Aerodynamics. Or 1 year. I have a good model, weather forecasting model, computational model, simulation code at my hand in my office. Then you need to have an input to there, input. Some maybe big 100 or 1,000, I don't know. Then simulation is going, and they have a prediction. That is simulation, weather simulation. Climate simulation. Now, forecasting, it is forecasting, prediction, right? Prediction of weather. Tomorrow, after 1 week, right? Hindcasting is trying to check my simulation code using already happened weather. Yesterday, model was wrong. 1 week ago, the weather was wrong compared to my prediction. Right. Hindcasting is check my model by using known measured data. How it's difference. I know already difference. Output difference, but input is I made input of say several hundred of input by adjusting, finding out the reason, adjusting the input, you may find out the correct input data or modify my simulation code. That is the goal of hindcasting. So testing mathematical or computational model of my weather forecast simulation. Climate simulation. So back testing. Collision simulation of a car. Let me show you a video. Right. See that? Once again. Yes. Right. Once again. Stop. Stop. It's not stopping. How can I stop it? This one? Yes. So collision test. new car, safety of car. Right? You need to. It is a law requirement that you need to have a test, collision test for automotive industry several times. This one, simulation, computational simulation. This one, real test. The real test cost is very big. You need to have a new car. Right? This new car is not made already for sale. It is under development car. So there is no car yet, only design is there. Right? So but I need a new car, new real car based on drawing or design. Right? How much money it costs to make that car for test? It should be handmade. Somehow. Not all handmade, but you can say handmade. Not mass production. One car manufacturing. Only one car manufacturing. So it looks like a very special car. Looks like a very special car for say racing model. They make very special best car out of engineering. Right? So it costs 10 times higher than ordinary sailing car, or maybe more than 10. The Kaiser, for the test, you need a facility, big laboratory, big building with a very strong wall, right? And then the car should run high speed, depending on the test model. And then also thousands of sensors to measure the shock forces, acceleration, speed, and strain, and stress, and many others. And measuring and sensing, recording, so that this one shows you what is saying, right? I don't know. But one is coming from the simulation code, one is coming from the test. And you see that very close, right? Then if you get this kind of match between real test and simulation, then you don't need to have a real test. If every time you have such a simulation result, then you can expect the weather forecasting. If the weather forecasting is fitting, matching, almost in this way, you don't need to have worry about very good simulation. But I'm saying that it is not so correct. Simulation is not so correct every time, especially for the new car. New car has no data, only appearing in the design model. And this one is very specialized made car for the test. But there is not so many data. So that simulation and prediction will not be correct. So this one is after doing many times of tests, many times of field testing and correcting the simulation. Then you can get such a good quality of simulation. That is the way. That's why hand casting is good and important for better prediction of forecasting. Right. Okay. So collision simulation of car, and we are doing, and secondary flow. And tea leaves, or many times it can be sugar. If you are putting sugar and stirring up to mix up it, you find out the remaining sugars are collected in the cell. Why? Why? Because you are doing rotation in this way. We'll see the video.
우리나라 직원들은 12% 정도만 몰입하고 있다고 되어 있었어요. 나머지 88%
では二次流れの実験をしてみます。まずたらいを手で回転させてみます。続けてこう回転を持続させると、この中の水は強制図の流れになっています。つまり容器と一体となって回転しています。お茶っ葉は外側の方に集まって遠心分離になっているわけです。次にこのたらいを手で回転を止めてみます。たらいは止まりましたけど、中の水は惰性でまだ回転を続けています。これをしばらく観察していくと、下に沈んでいるお茶っ葉はだんだん内側の方に集まってくるというのが分かります。これは二次流れという現象によって起こるものです。二次流れとはもともと遠心力で水は回っているわけですけど、そこに近いところは流れの速度
So that I do only rotation in this way. But because of this one, it's a viscosity and then centrifugal force create a secondary flow. This one is secondary. This one is primary rotational. The secondary is coming vertical way, and that make the tea leaves collected in centrifuge. And this one is another sample of secondary flow. So radially, we are in north sphere, secondary flow near go to zinc vortex surface. And then for the ocean flow, secondary flow gives a different phenomena for the ocean flow. Okay. Based on the wind creates flows, primary motions, primary flows. So that this one, and then the flow should follow the wind direction, but that the secondary flow goes the other direction in this way. But this one is changed as depth goes on. The direction also changes and magnitude also changes. Because the wind gives you the water surface of viscosity, and then creates a flow in wind direction. But the secondary flow goes in but the other side, orthogonal side. But depending on depth of the water, the viscosity propagation is different, so that magnitude changes, also directions are changed. So you can see that net water transportation integration mean of these secondary flows according to the depth, it can be in this way. So the wind is go on, and surface current can be the apparent movement of the water because of these complicated surface, but this is surface current, and net water transportation is also one of this. This one is named as Ekman layer or Ekman spiral in northern hemisphere. The deflection of surface current near current above. Not simple one, complicated, but it gives you different phenomena coming from these secondary flows. First one, coastal upwelling and downwelling. This is coastal region, United States. Los Angeles is nearby here, somewhere, right? Who is coming from Los Angeles? Not east side. You are coming from New Jersey, somewhere? Where are you?
I'm originally from California.
California. You know about this. Where is the Los Angeles state? Is it correct there or? I don't know, yeah. Anyway, see that this one is surface temperature. Surface temperature. That they found the surface temperature is different nearby. But you see that near the coast, temperature is low. Right? Temperature low. Comparing to the far away. Why? Why? Because water is coming beneath and come up over. Okay. Right? So this one is coming up. We call this upwelling of water. That's why this one is more cooler than the other far away. And this one is a reverse way, but this one may be coming from the rotational something. But this one is a main reason. And the wind is coming in this from north and south. And then surface current, the net water transport. Net water transport. Net water transport is right angle, orthogonal, 90 degree. So that net transport is in this way, right? Near the surface. Then the empty is here, so that the deep water, cool water is coming above. That's why this color is here and low temperature. The other way, if surface is going from the south to the north, the reverse phenomena is coming. Similar one. This one is wind is coming from the land side to the offshore wind. Then the upwelling is because of the surface direction, water is flowing in this way, net way, then need to have a upwelling. The other reason for upwelling is coming from current force and some kind of table mount obstacles. Naturally, it comes this. Here is the upwelling zone, surface current, upwelling. So water near the coastal zone is complicated. There is another one, Langmuir circulation. Water is circulates somewhere in this way and also in this way, so that water is going down here and then going up, and wind is the primary reason. So the net water transport is in this way, so that there is a streak of water, so that you can see such a phenomenon like this. Strips of waters, coloring, and also debris are collected there in this way. So you can find out this kind of water, and also these kind of phenomena. And then deep current was sometimes in the summer vacational season. In Korea, there are announcements or warning coming from the TV news that you should be careful about this kind of deep current or deep tide. So then water is transporting toward the far away. So if you are not swimming well, then you can trapped in these regions. You see the video.
You might have heard them referred to as undertow or riptides, but these ocean phenomena are actually rip currents. Rip currents are narrow currents in the surf zone that move quickly away from shore. A typical rip current ranges from 50 to 100 feet wide and can extend 100 yards or more offshore. It can reach speeds of over 5 miles per hour. That's faster than an Olympic swimmer. That makes them dangerous and potentially deadly, and scientists want to learn more about them so we can better forecast when and where they will form and keep beachgoers safe. Here's what we know. Waves don't have to be huge for a rip current to form. 2 or 3 feet are all it takes. And the weather doesn't have to be bad for a rip current to emerge. They often occur in the nice days after a storm. They're usually strongest near low tide, but can form at any time. Rip currents often form where sandbars are near the shore. They occur at breaks or channels in the bar. They're often difficult to see, but you can spot them in areas where waves aren't breaking, or where there's foam, seaweed, or discolored water being pulled offshore. It's easier to see a rip current from higher up, such as from the beach access over dunes or a lifeguard's tower. Rip currents are a hazard for beachgoers, but by knowing the dangers and what to look for, you can avoid being caught in the grip of the rip.
Right. It's saying that it is faster than Olympic swimmer. So can be dangerous. Right. Once again, wave energy escaping and stream of water is returning out to the sea from surface zone. A few hundred meters up going out offshore, then dissipate. So 100 meters is okay if you are swimming well, right? But if not, it will be dangerous. Oh. Question? Right.
If the person got caught in the rip, right? You just swim towards the way it goes.
I guess it can be better to go side if you can, because the stream is narrow and goes far away, several hundred meters. If you can go sideways, then then better to return or can say help.
During a rip current, you're supposed to swim horizontal or parallel to the shoreline. Or my friends, one of my friends passed me.
Really?
We don't know.
But usually it is you can swim well, then you can do anything without any buoy. But usually who cannot swim well, they use buoy, right? So buoy is maybe the target for and then you don't have less capability going out of the direction. Along shore current, so see that there is a shore there, and wave is incoming, and then current strength distribution. See, there is because of this incoming wave, you need to have a sideways direction of water stream. Right? It can be this way or it can be this way. So we see this is different from sea breeze, daily. You already know that the land side is hot, more temperature, higher temperature, air is going on. So the wind is flowing from the seaside in the daytime. In the nighttime, land is cooler, so that the reverse way. So land breeze and sea breeze daily is coming. That's all, because of this wind flows, the water current directions can be changed. Well, we already see this one before, right? The ocean surface current around the world during the period of NASA Goddard Space Flight Center Scientific Visualization Studio. Image. You didn't write this one. And this one is another one, similar one, but you see this one this time. But this one is measured, not measured one. I guess this one is simulated ones. That is my understanding.
생활비는 돌아온다. 생활 통장으로. 생활비로 돈 버는 세상.
No sound. MIT, there's it. Oh, it's dark. I cannot see where is it. Can you see this map? There's a greener land over there. Europe is somewhere here, so yeah, the quality is not good. When you see that October, November is coming and temperature somewhere, wind, current speed, meter per second. Something. And you can see from your notebook, it's better quality to see the image. Right, and then now the mesoscale is say something like a middle scale. Middle scale, not micro, not macro. The Goddard, NASA Goddard is a global scale stream, right? Global scale federal law, but this one is not smaller, but it is a medium scale. So that you can see where is North America, Florida, somewhere. So water tidal flows like this. Week one, cold water, warm water, and cold water is inside. And Gulf Stream, Gulf of Mexico is over there. And Gulf Stream is coming in this way. So that there is a rotational, and then there is an isolated waters. Rotational isolated. And also sometimes cooler waters, warm waters, inside cold water region, outside warm water. So that you can see that warm water isolation and cold water isolation because of this circulation of water. There's a scale eddy formation. Eddy is a rotational water. Scale is meso. So that in mesoscale eddy, we call this as a loop current. Right? Inside the Gulf of Mexico, and water is going this way, Gulf Stream. But because of this motion, you can get warm water circulation loop current and cool water circulation of eddy is something. Right, this one is a simulation code. And formation of this, probably this is warm water eddy formation, Gulf of Mexico, simulation date. And another one. Mesoscale to sub-mesoscale simulation, and they are saying vorticity. Eddy is related to vorticity. Rotational water motion is called vorticity. This one is a sub-mesoscale, so a little bit smaller than mesoscale. Small. And then it comes to the, because this of rotational eddies, water rotation, you will get this portion of gyres. There is also video. And all the garbage is coming from the land side is collected here. So it is a big problem now. You may find a way to remove or garbages. Yeah.
So a gyre is a natural phenomenon. A gyre is simply a rotating current system that's comprised of the Earth's rotation coupled with currents and prevailing winds. So it's essentially like a massive whirlpool, a vortex in the oceans. Say a piece of floating plastic from California in the North Pacific Gyre can take 10 years to make the rotation from California to Japan and all the way back.
So what we have found is that these plastic particles are not just in the North Pacific Gyre, they're in all 5 subtropical gyres, and all these gyres have several garbage patches in them, 8 garbage patches total in the 5 gyres.
So that was our inspiration to start the 5 Gyres Institute, to look at this plastic pollution issue on a global scale and try and show the world this is an international problem. These plastics are coming from every continent in the world, and solutions have to be on the international level. When I first heard this talk in 2001 from Captain Moore, I heard description of an island of garbage that people were calling the Great Pacific Garbage Patch. In the media, it was described as a Texas-sized island.
It's really hard to quantify how much plastic is floating in the world's oceans. These garbage patches that exist in the gyres, they're elusive, they change shape, they move around. You may trawl for 10 hours straight, you'll get a handful of plastic. You put it back in, 10 hours more, and there's nothing.
So it's essentially like a plastic soup of all of this disposable waste that we create on land masses, from California to Asia, Canada, Mexico, enters this North Pacific Gyre and gets swept up into this accumulation zone.
Islands in the gyres we're discovering are the natural nets for trash at sea. It's impractical to try and scoop out trash out of the ocean.
Okay. Question? No. Oh, this is the end of the slides. All right, then we can have a 5-minute break. I come back 42.
They went off of someone who gets sold. Like, I technically fit under the doorway, but I always put up my hand, because I do not feel comfortable with that close. It's the image.
So anybody who didn't check your attendance, please come here and check your attendance.
Question? No? How many people online? Many? 3, 4, 5, 6, 7, 8, 2, any? All right, this is question. You sure?
Or.
McQueen? Right.
I don't really understand about exponential spiral, but the exponential spiral is the exponential spiral here on
Indicator. Yeah.
because I feel like if both the lower product or the outside product got the same amount of wind, the wind, the wave pressure on the wave. Yeah. Because if the wind goes from same direction, right, for both north and south. And
This way or
that one.
oh, right.
And in that case, the wave goes for the
Waves goes together with wind, but they are already sideways. Going this way. Wave is surface or only surface. Wave is only surface. No wave in the pivot. Because of wind, wave is going in this way. But the secondary flow is the economic. This orthogonal. Wind is going this way. Secondary flow is going this way. Net water transfer. Then water should be coming from there. Very completely three-dimensional. So, interesting anyway. Any other questions? Alright, this one is for the discussion. How to do your discussion session. So 20 minutes for your session. Every time, 20 minutes. Lecture also 20 minutes. That is a target. Many times I found that you are very short. We're trying to make just time. It is another training. Trying to make short or long, but just in time is the best, right? Trying to do lecturing, discussion, anytime. You in your lifetime, you will get many chance to have a speaker speaking in front of people, right? It is training to make just in time, right? Student will, the leader, coordinator will lead 1 or 2 discussion session, but this time one time because we are many. When in last year, there was only 10 students. They should have a twice something. Flipped learning, classroom. Before the lecture time, this is a little bit different one, lecture video-based learning. So you should see the video first, but this time you can see the video from the previous semester. Very similar. And then at the now, present time of lecturing, we have a more discussion. That is the way of new learning modes. After that, you can have a check understanding. So we are trying to do new way of learning or teaching, so that flipped learning again. In old days, lecturing myself this way at the board. You are only listening, and then homework activities. Nowadays, lecture is going on video, and classroom you may have more discussions. That is the new way of learning our classroom. Coordinator, before discussion, prepare 2 to 3 topics, subtopics for this discussion of the day. Try to choose topics that are related with the lecture material, topic of the day. And during the discussion, lead the discussion so that students, the participants have a more talk rather than coordinate. Students can participate. That is important. Less talk from the coordinator. More talk coming from the audience. That is the important, good, better, but isn't. You will see that this is not easy. Group discussion. So many participation is better, more participation. Online meeting etiquette, it was shown in some days ago, some years ago when COVID was popular. We only have online classrooms. Preparation. After discussion session, please summarize and upload and post the discussion contents material to the class website or Kakao. He will help to upload to the website of the classroom. And brainstorming is another model for discussion. And sometimes students use this one as a small quiz to activate your participation. So try to. I don't know. You can choose. You're up to you. I just giving you a tips. Evaluation is big portion, 15%. Lecturing or discussion. So myself and 2TA will evaluate based on your submitted report. So submission is important, right? This submission, upload and file. All right. Question? No question? Then we can move on to second part of poster process. So wave is coming, the refraction, diffraction, reflection, and wave runoff and sediment transport. Wave. Wave is coming from the energy. Energy originally coming from the sun, solar energy that create wind. Wind create wave, right? And caused by wind. Commonly, not only, but commonly. Shallow water wave. As shallow water wave speed decrease, as the water depth decrease, and then wave breaks. So you see that this is wavelength L, and then water is circulating. Well, circulating size of the diameter is smaller, going down. You see that after depth of half of the wavelength, the water circulation movement is negligible, very small. So that wave is on the surface, not even. So that when storm is coming, you can escape to the pivot. Then you cannot feel where storm is coming on. So how deep? Half of the wavelength. Wave is long and short. There are many. Especially the storm is coming, wave is big and long. One example or application of this theory is that the fish farming in near Korea and East Asia, they have a cage of fishes because they can escape. The cage, there are so many fishes inside. Storm is coming. Sometimes the cage is break because of the storm. Right. Then you can get nothing, right? Every fish is escape. So the fish farmer, they submerge the whole cage down to the pivot. Half of the wavelength. Declination. Then storm is okay. No movement down. One application. Now, because of the water depth is going down and smaller than water break. So wind surfing, not wind surfing. What is this? Surfing. Wave surfing. What is it? Surfing board. Big wave is, I mean, we have beach surfing, Because of this phenomena, there is a wave breaking is coming. I will explain in details. Reflection is a band of wave directions. Crest. So wave speed change of wave due to depth. The water depth is low somewhere here, and also low here. So that wave direction is going this way, so that more erosion is coming. So that sediment movement is go in this direction so that you can have a quieter and sand beaches. Wave energy converging on headland, so that many times you see that there are only rocks remaining. Rocks, because of soils are going because of the waves. So these waves, only rocks are remaining because of the breaking of water, and the energy is concentrating over there, and sand beach is coming in. Reflection, refraction, and diffraction. Complicated, right? Reflection is simple. Change of direction, all change of direction. What means bouncing up. Reflection waves involves a change of direction also, but as they pass from the one medium to another one. So is the air there, water is down. So the light direction is changed. We call it the reflection. And diffraction involves the change of direction, all change of direction. They pass through an opening or around the barrier. See, diffraction. Diffraction is this one. Diffraction. There's a small opening. You cannot see that. This is a rock, and this is a rock. Between rock, there is a opening, small opening, and water is flowing these ways. Right? Reflection. So direction changes. Also, there is a opening, big opening, but because of this one, water is going round. Also, water direction is changing. Similar phenomena, wave diffraction. Wave reflection is bouncing off. So incident wave and going out wave. This way and this way. Incident ray and reflection. Oh, there's video. See.
Sun just set, and there's an incredible amount of physics to be learned. Looking at these waves and going through shallow water. What I'm looking at is waves traveling in towards the beach, and then waves reflecting out through the waves that are traveling in. Meaning waves coming in, bouncing off the beach, and reflecting back out. Now, while they bounce back out, you can see the...
All right, and then wave run up. There's a wave is going up to the beach. Right. And you should escape, otherwise your foot is wet. Right. This way, running up. So near shore or foreshore, maximum vertical extent of wave uprush above the still water level, and beaches, coastal protection structure. So the height and length and height. See that this one, and then sediment. Solid material that settles at the bottom of the liquid. At the bottom, Korean student, Sewol Ferry disaster. You may remember that the bottom of the water there, many different kinds of, many people are saying there's coarse sand or gravels because of the stream speed is high there. The solid material that settles at the bottom of the liquid, it can be a clay, it can be a fine sand, and medium, coarse, and depending on the situation there, especially the current speed of the water. So there is one video, I guess. No. So there is a sediment transportation, water is flowing suspension is inside the water. More smaller is a solution, not clear water there. And traction and Ibobes saltation or something. There's a video on it. No. Transport, how can you start to move this kind of ball or stone or gravel, depending on the size? There is a fluid drag, fluid force, and the friction from the surface. And there is a lift coming from the buoyancy. Buoyancy is, I will see in the later stage, but buoyancy is coming from the water displaced by the volume. This amount of water displaced by this object that gives you a lift force and gravity. So if you have a balloon here, then it should be a higher lift, bigger lift that you need floating. But this is a stone, so the lift is smaller than gravity. So that is one. And then you can calculate how strong speed or strong is the current, then you can start with the move based on this calculation. All right, sediment transportation this video. Ahen University. Somebody is coming from Germany. You know where is Ahen?
농막에는 물이 없어요. 집이 없었기에 수도를 안 넣어줘요. 그럼 물이 귀하지. So civil engineering usually goes through the land side. Ocean engineering goes to the seaside. Okay? But coastal region, in between. Also civil engineers working for lakes and rivers too. So coastal region is traditionally area of civil engineering. But nowadays it's between. All right. I guess this is the end of this slide set. Right. Now we have all this. Right. Coastal process is homework for now. Out of discussion. All set today. Question? No? Then we may have one more my lecturers on Thursday. We have a makeup classroom, and then go on to your probably less boring for this one. Question? Otherwise, see you on Thursday.